With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there is a uniform rod of mass 3m and length L which is lying on a smooth horizontal surface. Now, two particles of mass m and 2m moving with a speed 2 v naught and v naught in the opposite directly hit the rod perpendicularly at a distance L by 3 and L by 6. So this is one of the mass 2m with a velocity v naught. It hits and it is at a distance of L by 6 from the center. And this mass m which is moving with a velocity 2 v naught, it is at a distance of L by 3 from the center. Now, after from the midpoint O and stick to it after the collision. So they are sticking. Okay, so this would be essentially an inelastic collision. Now, if the loss in the kinetic energy of the system due to the collision is n by 5 mv naught square, we need to find what is the value of n. Now, since it is placed on a smooth horizontal surface, so we can say that this linear momentum would be conserved. So first of all, we just apply conservation of linear momentum. So this is conservation of linear momentum. Okay. So what would be this thing? So we can say that the net this initial momentum, this would be equals to the final momentum. Okay. So what is the initial momentum? Now, if we give this direction to be the positive direction, so we can say that 2m into v naught, 2m into v naught minus this is the linear momentum of this part. Now here, so this would be, so if we are giving this direction to be positive, so this would be negative. So it would be m into 2 v naught. So it would again be 2 m v naught. Now initially this is at rest, so its linear momentum would be equals to 0. Now what is the final momentum? They are sticking after the collision. So what it would be the total mass? So 2m plus m and plus 3m. This mass is 3m. So combined mass would be equals to 6m. 6m, and if they move combinedly, so that means they would be moving with a velocity of the center of mass. Now if we check from this part, we can say that velocity of center of mass would be equals to 0 because this term and this term, they would be cancelling. That means it would not having a linear motion, linear motion, it would be only rotation. So we can say that only rotational motion. Okay. Now if it is only rotational motion, so that means it would be rotating about the center. Okay, like this it would be rotating. So what we can do, we can just apply our conservation of angular momentum. Okay, conservation of angular momentum. Why? Because there won't be any external torque to this system if we consider these m, this 2m and this 3m to be in the system. So there is no external torque. Okay, so so before we calculate what is the before we apply the conservation of linear momentum, first of all we just calculate the value of the this moment of inertia about the center of mass. So moment of inertia about the center of mass. So it would be for the rod. The this is 3m, mass is 3m, and the length is we say that the length is L. So the this moment of inertia would be equals to 3m L square divided by 12. Okay, this would be the case because for the rod it is equals to ml square by 12 about the center. Now mass here is 3m. Now for the other mass, so one mass is at a distance of L by 6. So 2m into L by 6 square because this is the point mass. So m into r square. Distance would be L divided by 6 square. Now for the m mass, the distance is L divided by 3. So m into L divided by 3 square. Because for the point mass, the moment of inertia is mr square. Now if we calculate this, then moment of inertia of the combined system, this would turn out to be 5m L square divided by 12. Now we will apply conservation of angular momentum. So initially this is having a velocity, this is having a velocity. Okay, they both are having the velocity. Now how in which direction it would be causing rotation? So it would be causing rotation about, if we just calculate this linear momentum about this point. So it would be causing rotation like this. Okay. Similarly, this would also cause rotation like this. That means they are causing rotation in the same way. So their this angular momentum would be added, not subtracted. Compared to the linear momentum which was subtracted, their angular momentum would be added because they will produce the same sense of the rotation. Now what would be the angular momentum of this part? So angular momentum is m into v into r, where r is the distance, perpendicular distance from the origin. Now m is 2m, velocity is v naught, and what is the distance? So not distance from origin, but about the point of rotation. So the distance would be L divided by 6. For this, mass is m, velocity is 2 v naught here. Now what would be the value of r? It would be equals to L divided by 3. Now we just put the value. So initial angular momentum, first of all, we just write. So 2m v naught L by 6 because it is at a distance of L by 6 plus m into 2 v naught, and it is at a distance of L divided by 3. Now the whole system is only rotating. So about the this center of mass, so we say that it would be equals to I into omega. Now what is the value of I? It is equals to 5 ml square divided by 12 into omega. Okay. Now from this expression we can get the value of the omega. So omega, or the angular velocity, it would be equals to 12 v naught divided by 5L. Now this is the angular velocity. Now we have been given with the expression of the loss in kinetic energy. So first of all, we calculate what are the kinetic energies. So kinetic energy final. So in the final case, it is just rotation. So it would be equals to half I omega square. So it would be equals to 1 divided by 2. I value is 5 ml square divided by 12, and omega value is 12 v naught divided by 5L, and we need to square this. Now if we find what is the final kinetic energy, it would be equals to 6 mv naught square divided by 5. Now what would be the initial kinetic energy? So initial kinetic energy would be just kinetic energy of the masses. Okay, mass m and 2m. So it would be, for the 2m, it would be half into mass is 2m and velocity is v naught. So square plus 1 divided by 2, other mass is m and the velocity is 2 v naught. So square of this. So it would turn out to be 3m v naught square. Now what is the loss in kinetic energy? Clearly we can see that initial is greater than the final. That means there is a loss in kinetic energy. So what is the loss in the value of the kinetic energy? We can just take the difference. So 3m v naught square minus 6m v naught square divided by 5. Now if we solve this, then our loss in kinetic energy would turn out to be 9m v naught square divided by 5. Now this loss is given as to be n divided by 5 m v naught square, and we need to find what is the value of n. So if we just equate this with n m v naught square divided by 5, so what would be the value of n? N value would turn out to be 9. So this would be the correct answer for this problem. N value would be 9. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.